with a radical equation with a variable index, with a variable radicand, and with a variable right-hand side. So this is a true equation. We're looking for x, real number. I guess it's possible these kind of things can have complex solutions, not really sure. But anyway, we're looking for a real solution. Now, so it's a lot more convenient here to rewrite this expression with a rational exponent. That's more operational. It's just easier to do computations. And you can see right here, that's exactly what I did. This part right here becomes the numerator of the rational exponent. This index right here, 6x, becomes the denominator. Now notice our first big leap here is to divide through by x, and that's because x equals 0 is not a solution to this equation unless you believe that x raised to the 0 is equal to 0. So we could divide through, cancel the x's freely, since x equals 0 is not generally considered a solution, or not ever considered a solution, this thing, I think. All right, I think you'd have a divide by 0 going on as well, probably. Okay, so anyway, we get this simplification right here. And then now we can rewrite this. This negative exponent, if you recall, really means put it in the denominator. There's actually a nice justification for that if you go all the way back to the proofs of why these properties hold. But what we really have going on right here is a 1. That whole thing raised to the first power. And this 2 gets left out as the index of the radical frequently, which leads to confusion. But anyway, this 1 and this 2 that you see are exactly this 1 and this 2, and the negative sign means to put it downstairs. A lot of rules, but once you see why the rules are true, they're not hard to remember. Okay, now at this point, all I did was square both sides. Now I think it's you could have squared right here and gotten to the same place I'm about to get to. I just like doing it this way. I think it's cleaner. I like the look of it. So when you square both sides of this, you get this statement right here. Okay, you get 1 over 8x. Now notice that squaring may introduce extraneous solutions, so we'll check that later on. But anyway, if you continue right here at this stage of the problem, you would get 1 over, multiplying through by x. Okay, we get 1 over 8 is equal to x cubed. Right, and if you cube root both sides here, you get 1/2 is equal to x, which is our proposed solution. Okay. Now you could stop right here, but why don't we take? I guess you could stop, but let's. A lot of people, a lot of presenters don't check their answers. They just stop when they get an answer. Now, so let's put the 1/2 back in here. Okay, so I'm gonna just rewrite this right here. Y'all, this is the check face of the problem. And again, I'm taking this 1/2 and placing it right there. So we're going to get a cube root circumstance right here. Reads cube root. 8 times 1/2 is 8 divided by 2, which is 4 last time I checked. So you get 4. And then to the minus 3/2, raised to the minus 3/2. The Zoom interface is working a lot better. I don't know if it's the Zoom or the Wi-Fi is just better. Okay, folks, so again, now notice I'm not saying it's equal to 1/2 because this is the check, okay? This is the check. Okay, we're checking. This is the check phase of the problem. Verification, solution is accurate. Now, y'all right here, this negative exponent means the same thing. It means 1 over all that, but that would be 1 over the square root of 4 cubed. So this actually gives us the cube root of 1 over 8. Okay, which is certainly equal to 1/2. And so we can put a check mark. Again, folks, if you don't see where this came from, this part right here would just be 1 over 4 to the 3/2. Or exponent, rational exponent of 3 halves. And the half there means to take the square root of 4, which is 2, and then the cubing means to cube 2, which is the 8. See right here. And it does check. So that is a solution. Now, I didn't prove it's the only solution, but I sure believe that it is the only solution. I don't know if you really have to prove it. It's the only one we got. We multiplied through by x, which again could have been introduced an extraneous solution, but